Okay, today guys, we're starting 10.3 geometric sequences and series. So today is the geometric. Here are a list of our objectives that we're going to be covering. So to find the common ratio of a geometric sequence, to write the terms of a geometric sequence, to use the formula for the general term of a geometric sequence, to use the formula for the sum of the first n terms of a geometric sequence, and to find the value of an annuity. Sorry about that. To use formulas for sums of infinite geometric series. So we're going to begin by the definition. A geometric sequence is a sequence in which each term after the first term is obtained by multiplying the preceding term by a fixed non-zero constant. The amount by which it is multiplied each time is called the common ratio of the sequence. So we're going to begin with the first example. It says write the first 6 terms of the geometric sequence with which with first term 12 and common ratio of 1/2. So we know our first term. Let me change colors. I'm in yellow because you know it's my favorite, but I know it's not always the easiest to see. So our first term is going to be 12. Our second term is going to have to be 12 times that common ratio, which is going to give me 6. My third term is going to be 6 times that common ratio, which is going to give me 3. My fourth term, it's going to be 3 times 1/2. It's 1.5 or 3/2. My fifth term is going to be 3/2 times 1/2, which should be 3/4. And my sixth term is 3/4 times 1/2. It's going to be 3/8. So I now have my first 6 terms of this geometric sequence. We have a try it yourself. So our try it yourself says the first term is 6. And common ratio is 1/3. And we'll write out the first 6 terms again. So our first one is 6. Our second one, first, probably how I should be doing it, second. So it's going to be 6 times 1/3, which is 2. And then third, it's going to give me 2 times 1/3, 2/3. Fourth, 2/3 times 1/3, 2/9. Fifth, 2/9 times 1/3 is 2/27. Sixth, 2/27 times 1/3. Okay, sorry guys, I'm going to do it on here. I'm pretty sure it's 81. I just want to verify. Yeah, it is. Okay, 81. 2/81. Okay, let me know if you see any errors there. Thanks, guys. Let's go on to our next one. The nth term, or the general term of a geometric sequence with first term 1, a sub 1, and common ratio r is given by a sub n equals the first term times the ratio raised to the whatever number you're on minus 1. So make sure you take a second and write this down. We're going to be using it. Okay, so this example says, find the 7th term of a geometric sequence whose first term is 5 and whose ratio is -3. So we know we're trying to find n equals 7. Our first term, a sub 1, is 5, and my ratio equals -3. So we're going to use that formula from the last page. A sub n equals a sub 1 times my ratio raised to the n minus 1. So we want to find a sub 7. 5 times -3 raised to 7 minus 1. So it gives me 5 times -3 to the 6th power. I'm going to put that into my calculator all at once. You guys do that as well. Okay, and I think this is what I get. 3,645 a sub 7. Thank you. Let's go on. Okay, The next one is, again, a try it yourself. So find the 8th term of a geometric sequence whose first term is 4. So we're going to find n equals 8, a sub 1 equals negative 4, r equals negative 2. So we use that same formula, a sub n equals a sub 1, r to the n minus 1, a sub 8 equals negative 4 to negative 2, 8 minus 1. Okay. 2 to the 8th, or 2 to the 7th. So give me a minute. I have it as 128, negative 128, double check me, times negative 4. Gives me 512 as my answer. 2 negatives make a positive, so my 8th term would be 512. Okay, so I'm still trying to break these up into some smaller lessons, so we'll stop here and try your Google form.